resistors are grounded and they have them.
Good evening. We are using a 680 ohm resistor.
I've done the, for 7476, I've done the presets and the clears. I've set all of those to ground.
And also a 1K resistor. AC.
Yes, sir. 13, yes, sir. Okay, I've done it. I've set the clock to my switch 1. That's my logic, so I put it in A here. And I put it to number 1 here. And this clock went to 15. That's number 6 that went to 15.
The negative of channel A should go to the ground, so all the way to the bottom.
My presets and my clears.
To that bottom corner, that corner right there.
And be here, right? What's our voltage?
Voltage is 1.7675.
Our voltage will be 1.7675 at frequency 500.
I have the ground and the ground and the VCC.
And we will add a voltmeter.
Which one?
For resistor 2.
These are 74, 76, so you only need one. 4, 6,
Measure R, to measure IN.
I can definitely show you some tricks and sort of.
As well as a voltmeter for resistor 2.
The first thing you want to do
vertical
is usually your first
voltmeter.
will always be your source. It's just sort of easier. B will be here. The channel B. So we can double on that. You run it, you get this, and it's going to kind of look a little weird.
Yeah, and then I was trying to
876.
to stop that. When you hit that,
That's
Just same thing. So when you're running it, it's going to run. And then the time
We are going to make sure our voltmeter is set for AC on both of them.
okay, yeah, the one.
Yeah,
Time is
that's the horizontal.
So we need 3.
We are now going to open the oscilloscope
So the same thing, one thing I can show
and
you here,
make sure we are
one of
on
the things you
AC.
can do is based on the X value.
Channel
So I
A
can
and
move
B are
this,
showing.
let's say, to the left.
We can
and
cancel
it'll
out
actually
B.
ask me for an X value. So if I say 0 here, it's going to move to the left. to the
Let's
next
make
line.
it so we
So
can
the
only
next
see
line will have
one.
0. And then I can move this to the right
That's
to the
good.
next Y0. And then this distance between the
Oscilloscope again.
While the scope
We will be
actually
measuring the
so you can
peak.
get
the whole AC.
yeah,
So
you can actually see it sort of
next
Y.
next.
And so you can actually get the peak value. You can get peak to peak. You can get RMS on a scope as well. You can get average.
But even if I use the scope, I could get this
Yeah.
this result from our.
There is a in the measurement tab you can actually select RMS.
Can we look at it real quick?
Yeah.
You don't have this.
Well, no, right?
Is that all of that on there?
That will be.
Okay, so we've already done that, that's what you're saying? Pretty much, yeah. Okay.
I don't know what I'm
It's
saying.
4.999 volts.
There you go. 4.999 volts. The VRMS. We can close the oscilloscope and look here. Is 0.715.
So you click that, and then it would pull it up. It looks like it's already selected.
The time,
This is from someone else.
the period,
Yep.
will
That
be
should be pretty nice.
peak to the peak here
On
on a full cycle.
I was gonna get into so
And,
much detail,
Oh man.
but I didn't even have to.
There's nothing wrong with that.
Yeah, I
That would
know.
be 2
He probably
milliseconds.
would have been impressed.
We are now going to measure channel B. We are clicking on the oscilloscope again. Let's get a good reading. Make sure channel B is selected
That's more for calculating. It's
on
actually
AC.
kind of like, where does the period
And get rid of channel A.
That's more.
We need to zoom in or zoom out depending on what we need to accomplish. That's not the right way.
You're adjusting channel A.
But,
Oh.
so like, is this one period here? From here to here?
Ooh, that's perfect.
But,
Okay.
this is.
Let us measure
In other words,
peak to peak.
It's more like, it could be from any point. This is just a really easy starting point. So like, if I keep my fingers in the same spot, and move them, it's like, the time in between doesn't actually change. It's just sort of, it's where the waveform starts.
Okay.
So if it's going this way from here,
Um,
next spot, it's not.
voltage RMS.
So like,
We can
this just runs through it, but this isn't a full period.
is right here, 2.976.
Coming up this way,
It's your peak to peak.
We got one.
And that's our peak to peak.
you need to essentially count.
Our voltage across that resistor is 1.052 volts.
So since you're
The time
right now,
for one full cycle will be
yeah.
2 milliseconds,
So,
which
um,
you put over 1,
but since you're technically,
and the frequency will end up being 500
Hertz.
hertz. That was
So now I'm going to demonstrate how to set up that same circuit from multisim here on the bench. I'm going to start by putting 2 wires on our positive, 2 positive holes.
so that's just about the same thing that you got here. So it's
One is from the function should be coming from the function generator, and the other one should be is for your multimeter reading.
the waveform is
And I'm going to set up 3 ground cables.
I'm talking about number 13, are you talking
now
about?
you can do the same thing, like,
Okay, it's display, that's all. I'm
2 for your oscilloscope and 1 for your multimeter reading.
instead of going out
And I'm gonna put in series the 680 ohm resistor. One goes in the positive, the other one goes down to the rest of the breadboard. And 1 kilo ohm resistor in circuit with the 680 and down to a negative hole.
yeah. So we could say, like, this is 0.2 here, and that's about, or maybe 0.4. So how do we do it?
I'm gonna add just 1 more ground wire because there are 2 channels of the oscilloscope. One of them is going to be for the function generator and the other one for the multimeter reading. So now we hook up our function generator cable over to the function generator all the way to the right side. This half of this equipment is the function generator. And if I turn it on, we can set it right away to 500 volts. Right now it's in 5 kilohertz. I'm sorry, 500 hertz. Right now it's at 5 kilohertz, so we need to bring it down to hertz and tweak it to 500. And we have our regular probes for our multimeter.
So you just calculated 1.28 volts peak to peak. So now we need to.
It's reading voltage, and we need to make sure that we set it to AC.
It's gonna zoom out of scale, so we'll have to bring that down.
And last but not least is our digital oscilloscope.
So there's a horizontal.
We have 2 oscilloscope probes, one hooked up to channel 1 and the other one hooked up to channel 2. Let me go ahead and untangle them. So this one's channel 1 and this one's channel 2.
Oh, yeah.
So now we're going to make the connections and hook up all of our probes. First I'm going to do the function generator.
And then just sort of tune it.
That's basically our voltage. Positive goes to one of the positive wires. Negative goes to one of the negative wires. Next I'm going to hook up our multimeter. Positive goes to one of the positive wires. Negative goes to one of the negative wires. And last but not least, I'm going to connect the oscilloscope probes. Channel A was connected to the left side of the first resistor. I'm going to hook up the ground to one of the ground wires.
He will be back tomorrow.
And channel
but
B
he has a
was hooked up
tomorrow
to the left side
is a test,
of
I believe, from 5 to 7.
resistor 2.
So yeah.
This thing is kind of big. And we're going to hook up the ground to the last available ground wire. And now our circuit is fully connected and ready for measuring. So now I just want to make sure that everything is set just like the way we had it with our function generator, like on multisim. We have it at 500. We need to make sure on our multimeter is reading the 1.7675 or something close to that voltage RMS. So I'm going to change the range in our multimeter so you can see a more accurate reading. And I had it set, but I'm just going to tweak it just a little bit to get a closer
5 at the top and 5 at the bottom. So
and more comparable measurements.
So yeah, 5 divisions.
I'm playing with this knob here that says amplitude. It's right above the connection on the function generator. And it's very sensitive, so minor tweaks. 1.765, 1.766, it's more or less what we had there. So
That's what your scale is, right?
that should be okay. And now we're ready to perform our measurements. So now we're going to acquire all the measurements in the new school way. Just a reminder, if you want to reset your oscilloscope, you can just click auto and both the channels will come back. So first we're going to do it across the voltage in. We're going to get rid of channel 2.
Pretty please, I'm coming to you. Don't come to me, I'll come to you.
And now we're going to measure the voltage peak to peak. So we just click measure. We click on this button for voltage. And we use this little knob to scroll down to voltage peak to peak and push it in. And we get a value reading right here. And you can see that it's 5.08, very similar to the reading that we got on multisim. Now we can measure the voltage in RMS. So we click voltage, and if we scroll down a little further, there's VRMS for voltage RMS, and we can click it, and we get that reading right there, which is 1.78 volts, which is also very similar to that we set on multisim. Now we can also measure the period by clicking this button, time, and actually the first one is period, so we can just click it, and it's being blocked by the measure menu, so let's take that out of the way. It cleared it, so let me just go ahead and do it again. Period. There's your period, which is 2 milliseconds. Fluctuates just because it's the real world, but that's that reading. And we can also bring in the frequency measurement by clicking time as well, and the one right below is frequency. So we can click that and we get the 500 hertz. And now we can repeat the same process for the measurements across resistor 2. All we do is get rid of channel 1 and bring up channel 2. And now we can go ahead and click measure and bring in the reading for the voltage peak to peak.
Yeah, 179? Okay. So you could do like 2 volts per 100?
Sometimes the readings don't show up properly, so you can go ahead and reset the oscilloscope by clicking auto.
179.
Okay, so for this portion of our video, our camera decided to delete all of our videos, so I'm going to have to show you the pictures. So to measure the voltage peak to peak, what you're going to do on your oscilloscope, you're going to set up your wave so it starts on the 0 line, and you're going to adjust it with the horizontal lever on your right, and you're going to bring the wave all the way down so it balances out basically on the 0 line, or until it's right on the screen before it's completely gone, the bottom of the wave. And for that, you have to count the squares from the middle. If you look on this picture, the second sine wave, you can count 5 squares up, so that would be your voltage peak to peak. And for this one, to figure out the voltage RMS, you're going to take your peak to peak, which was 5. You're going to put it into the formula. So you take 5 divided by 2, as you can see on the screen, 2.5. And then you times that by 0.707, which equals 1.7675 voltage RMS. For this next part, you're going to want to measure time or frequency. So what you're going to want to do with your oscilloscope is you're going to want to set it back up to where the end of the wave begins basically on the 0 or neutral line. And you want to measure as it goes from the start of that wave and goes into the upbringing of the next portion. So you're going to count 4 squares across on this next screen, and just make sure that your channel 1 is checked. That way you know that you're measuring channel A. So with that, you're going to measure 4 squares across. Okay, in this portion you're going to take time, frequency, and you're going to work out the math. So the 4 is the number of squares that we've counted. This number right here is the 500 microseconds. So you have to multiply those two, and then you divide it by 4, which comes up with 2 milliseconds, and that would be your time and frequency of this portion. You're going to go ahead and do channel B as well. So what you have to do is you hit the channel 1 until the button is no longer lit. That means that you have officially gotten rid of channel A, and you're going to go ahead and just measure channel B. So you do the same exact thing as before. You adjust the horizontal lever, you bring the wave down, you bring it so it's even with like the bottom of the screen, and you're going to count the squares all the way up to the top of the form, and then that would be voltage peak to peak is 6. So then you take, for the voltage RMS, you're going to take 6 divided by 2, which equals 3, and then you multiply that by 0.707. So our voltage RMS for channel B is going to be 2.12 voltage RMS. I'm going to go ahead and just, while we're going to do time and frequency, correct myself from the earlier video. You're not going to end up dividing it by 4. You just take the 4 times the 0.0005, and then you get your 2 milliseconds. So you do the exact same thing. You have to measure the whole waveform just as you did before. So you adjust it back to where the curve hits that neutral 0 line, and then you also have to count the squares between that portion to the curve where it crosses that middle axis, and you have to count the squares in between. So you got 4 for that. So you're going to take the 4 times 0.0005, which equals 2 milliseconds. And that is our time and frequency of this channel B as well as channel A.